Okay, so we're going to do a quick review of how to sum torques, just with a little example problem, just to refresh that. So the problem I'm going to be working with is this. We'll have a little bar here. It's up at an angle off the ground of like, I'll call this one 30 degrees. And then we've got, it has a weight right here. The bar has a weight, right? The weight is acting at the midpoint. Its center of mass is where we treat weight to be acting. We'll say 10 newtons. And then we'll also have a external force, like a rope being attached here at the end, that's, say, pulling with a force of 5 newtons. And last but not least, there's a little length here. We'll just call that the bar is a length of 1 meter for simplicity's sake. Alright, so that's our little setup. And the question might be asking you to do something like sum torques about, or well, it might say find the net torque, right? Which would be, generally speaking, would be around this pivot point right here, right? Which is on the end. You always need to pick a spot that you're summing torques about. So yeah, we'll get started. It's just pretend we're looking for, like, what is the net torque? Question mark. So it's just simply summing the torques. So we need to write a sum of torques statement, a net torque statement. Net torque. Remember, we need to define which direction is positive and which is negative. Generally, right? We've said that I've said that we usually take counterclockwise to be positive. But remember, you can define which way that is. Now, if I'm looking at both of these, right, they're actually both going to make it want to turn to turn clockwise. So I might as well make clockwise positive in this case, right? So that I'm just dealing with two positive values. So I'm going to call clockwise positive, and that's how I indicate, right, that it's going this way with a little plus sign in the middle, right? So clockwise is our positive here. And generally, you'll say you need to define like what you're summing about, because you can choose that arbitrarily as well. Here, it makes sense for us to just do that left side. So I'm gonna say the left side, or even like the pivot point. So I'll just write the pivot point, I guess. We're finding the net torque about the pivot point, and we're calling clockwise to be positive. This is all just to help you keep track of your signs and things, and where you're measuring from. So these are technically optional pieces of information, but they're all important to the way that you're calculating it, so I'd recommend writing them down to remind yourself. So that is equal to, it's clearly not standing still, right? So it is accelerating. We're really just looking for the net torque, though, so we don't need any like rotational inertia times acceleration. We're just trying to find the net torque, so we're just going to write our equation now. So we've got the torque due to the weight here, right? I'll just say that's the torque due to the weight. And then we've got this torque due to this external force here, right? Both of these are going in the clockwise direction, so they both have positive signs. So the torque due to the force F. Sure, we'll call that F, I guess. And they're both going in the same direction, positive direction, both going. They both want to make it turn clockwise, so they're both positive because we've said clockwise is positive. Okay, so how do we calculate torque? Remember, torque is the force times the perpendicular lever arm, right? Force that's being applied times the lever arm that is perpendicular to the force itself. The lever arm being the distance from the force to the pivot point. So, I guess let me rewrite this as like, so the weight, the force of weight is, right, it would be like the force of gravity. It's this 10 newtons here, and then times some lever arm, which we'll get into, plus this force, which would be just our force F, which would be the 5 newtons, times a lever arm. So force of gravity, easily, that's our 10 newtons here. The question is, what is our lever arm? What is our perpendicular distance here? So I'm going to skip past this one for a second because this one's more complicated than the other one. We'll start with the easier one to determine. So our external force here is 5 newtons, and our lever arm here, right? This force is perpendicular effectively to the lever arm here, right? So this perpendicular distance is that whole 1 meter, right? 1 meter. So this is the easy way because this force is already perpendicular. This distance and this force are already perpendicular to each other. So that's some easy math. But now this 10 newtons, right, is acting straight up and down. So what we need to find is the perpendicular distance from this to the pivot point, right? And your easiest way to do that is you can extend this force down here, right? These things are perpendicular to each other. So if we find this distance right here, then that would be our lever arm. So how do we do that? Well, I'll bring this down a little bit, right? So I draw this a little bit bigger so we can see this. This is 1 meter here. Then we've got this force, and we're looking for this distance, right? So this angle here is 30 degrees. The weight force, right, is occurring at the center of mass, which would be in the middle of this beam right here, right? So this hypotenuse side is 0.5 meters. And we can just use trig, right, to find this distance right here, because this would be the perpendicular distance. This would be the lever arm. So we have hypotenuse, we have this one, we're looking for the adjacent side, right? So we would use cosine. So our formula to find this side here, right, would be hypotenuse times cosine of 30. So 0.5 cosine of 30 degrees. Right? That would be our, that would be how we find our lever arm here. It's the perpendicular distance between the pivot point and the force that's causing a torque. So we're ready to do math. So just 10 times 0.5 times cosine of 30 is 4.33 whatever plus 5. So our net torque, about the pivot point, taking, clockwise to be positive or whatever, is 9.33 newtons times meters. Remember, torque doesn't have a very pretty unit. It's just newtons times meters, force times distance, right? So yeah, that's our net torque. That's how you do that. You are ready to take on any other questions. Bye.